Welcome to the Explainer. Today we are diving into a really interesting set of documents that outline a novel and, let's be honest, a pretty unconventional theory about our climate. It challenges some of the most fundamental ideas we have about what's happening to our planet. Okay, so let's just jump right in with the huge question this whole thing is built on. We hear about carbon dioxide all the time, right? It's the main character in the story of climate change. But this framework starts by asking, what if that focus, while totally important, is also tragically incomplete? And this analogy from the source material really frames their whole argument. The documents point out a pretty stark mathematical reality. Right now, our efforts remove less than 0.5% of the CO2 we produce each year. They're basically saying that at this rate, we can't possibly solve the problem in time. It's like we are obsessing over the spoon while completely missing the volcano that's actually heating the water. So, if the argument is that CO2 isn't the only thing we should be worried about, what does this alternative model want us to look at instead? What's the volcano in their analogy? Well, they introduced something called the Morphean Climate Hypothesis, or MCF for short. Now, it doesn't say CO2 doesn't matter, not at all, but it says it's just one piece of a much bigger puzzle. It suggests that the temperature changes we're seeing are a combined result of our vast electromagnetic grid, tiny industrial byproducts like nanoparticles, and even the leftover isotopic residues from the atomic age. It's a whole different way of looking at the problem. And this isn't just some vague idea. They've actually put it into a formal equation. What you're seeing here is their core model. That delta T just means the change in temperature. And it's presented as a weighted sum of all these factors. You've got EM for electromagnetic infrastructure, NP for nanoparticles, and ISO for isotopic residues, all there next to the familiar CO2. Each one gets a weight, which means the model is trying to figure out exactly how much each of these things contributes. Okay, so let's actually break down what these unseen drivers are, at least according to the source materials. The theory really zeroes in on these three big factors that it claims we're mostly ignoring. First, EM. That's the sheer density of all our electronics, our power lines, our cell towers. Second, NP, or nanoparticles. Think of all the microscopic stuff we create, from microplastics to industrial dust. And finally, ISO, which is the long-lasting fallout from atomic tests and accidents. Now, to understand their climate model, you kind of have to understand that it's built on a completely different idea of physics. So traditional physics talks about particles in empty space with these abstract forces acting on them. This Morphean framework, though, it proposes a universe that's totally filled with physical structures it calls exobarriers, all packed together with no gaps. So in this view, a force isn't some invisible field, it's an actual physical mechanical interaction between these structures. And here is the crucial point. Because this framework is focused on these different drivers that have exploded in the modern era, it also proposes a radically different and, frankly, a much, much more urgent timeline for action. This slide really lays it all out. You've got the mainstream view, which often looks out over 100 years or more, but the MCF zooms in on the last 70 years or so, starting around 1952, which it sees as the beginning of this massive electromagnetic and atomic expansion. And based on that, it makes a startling prediction, a potential systemic breakdown, something the source calls a harmonic collapse, basically an irreversible domino effect of environmental failures in as little as 15 to 25 years from now. To back this up, the source material makes an incredibly bold claim. It says that when you take its model with these new drivers and you plot it against the actual temperature data from the last 60 years, you get a correlation of about 0.995. Now, to put that into perspective, a perfect correlation is a 1. In a system as complex and messy as the global climate, getting a number that high is almost unheard of. It suggests a near-perfect statistical fit. And here's where things zoom out, like way out. This climate model, it turns out, doesn't just exist on its own. It's presented as just one application of a much, much broader cosmological framework. The whole thing is built on this one core idea they call orthogonemy, and the concept is that the universe is, at its root, a perfectly logical and non-contradictory system. So if we see a paradox or something that doesn't make sense, the theory argues that the problem isn't with reality, it's with our models and our way of observing it. And this is where the theory makes its most ambitious connection of all. It proposes that these universal harmonic principles, like the golden ratio, are the literal building blocks of everything. This slide highlights a specific claim from the source, that the very geometry of our DNA is governed by the same mathematical ratio, which suggests a deep connection between biology, physics, and yes, even the climate. Which, leaves us with this final, really provocative question. The source material we've looked at today presents a framework that tries to link literally everything, from the cosmos down to our own DNA. And it forces us to ask, for a theory that's this ambitious, that claims to explain everything, what would it take to prove it? What level of proof do you need to rewrite the very foundations of science?